intelligence and the evolving landscape, kind of how we got here, what we're doing here, where we need to go in the future, and some of the challenges that we've seen with customers. Did I do an okay job explaining that, Jeremy?
Yeah, absolutely.
Fantastic. Well, Jeremy, why don't you introduce yourself to the audience, since they tend to know me pretty well at this point.
Yeah, so I'm Jeremy Turner. I'm head of cyber and risk at Cogility. And I work on developing a cyber threat intelligence product called Tacit Red, which is a subcomponent of the Cogility product offerings.
And who is Cogility? Like, where can we find Cogility? How long you guys been around? What do you all do? Give me the ELI 5.
Yeah, there's quite a history for Cogility. The Cogility really started off as a software development shop, engineering specific solutions for the Department of Defense. They have their roots in some things like counter IED detection and other really interesting concepts, really evolving around data analysis and intelligence production. That kind of evolved into some active programs like Counter Insider Threat and others within DoD. And also, it's when I saw this application and what they were using it for, I immediately kind of saw the capabilities and was just like, wow, this can really help solve a lot of problems that are in the the cybersecurity field and in the threat intelligence space, just by its ability to very easily expose UI components to users and allow them to engineer and deploy patterns to stream processing jobs. So it really brings the analyst closer to the data and the problem.
Excellent. So as we think about threat intelligence, right before this call, we had this really interesting kind of discussion about most of threat intel is querying a database of logs for some sort of response, right? Kind of the standard thing, right? I create a query, I get a response, I create an alert, that alert goes out. However, and I had this conversation with the customer yesterday, right? Managing the quantity of data has now become the biggest challenge with doing any of that. Like, even if the queries are really good, even if the queries are really tight, and I'm not getting a bunch of false positives, right, from the quantity of data, the quantity of data is growing at such a rate, it becomes almost untenable from a cost perspective and from kind of a real-time perspective, right? Like, how do I process the data fast enough to be able to get access to it fast enough that I can respond fast enough when, we're in security? So seconds count in a huge way.
Absolutely. Yeah, and it's kind of what led me into this looking for solutions in stream processing. I was working previously with a cyber insurance company, and when the company was small, it was really easy to handle a lot of the analysis and the cybersecurity risk analysis for all these different companies. But as the company grew, this concept of running scans and storing the data and then querying it to generate reports became almost unsustainable from a scalability perspective. And that's really what, I just kind of fell in love with this different approach of it. Instead of, doing these batch queries and, very long, complex patterns that we're trying to search for, really a real-time stream processing can offer a tremendous advantage to those analytic workloads. And because we're doing it in real time, where those seconds matter, you're able to get those insights very rapidly. And you can build upon them, just like different functions. You can have looking for one specific type of behavior, and then you can have a statement like, well, if the file is downloaded and it generates a new process and it reaches out to a domain, what are the properties of that domain? So going through the whole process that an analyst would do on a hunt, you can deploy these jobs statefully or configure a stream processing platform to do the analysis and progressive analysis based on all those conditions, and do it much more effectively. Even being able to handle very large data sets that are typically unruly, when you're talking about like terabytes of data per day, storing that data over a longer period of time becomes very costly. It also becomes very computationally intensive to query. So when an analyst knows what they need to look for and they can construct patterns in their mind of the different types of hunts that they're after, being able to deploy those and get that data in real time is a much more effective manner to kind of root out the interesting findings.
So that sounds really complex. Sounds like a lot of work, right?
Yeah, it is a lot of work. The process for an analyst right now that's doing a lot of different queries, it's either they have lots of batches or they're progressively kind of working through and pivoting around indicators to get to their conclusions and their findings.
So what do you so how does this new methodology change that work, right? Because threat hunting is a lot of work, kind of period,
Yeah.
right? So does this change the work? Does this reduce the work? Like what's from an operating model standpoint? Like I understand the results are going to be much faster. So from an operating model standpoint, how do my humans operate differently to become more efficient?
Yeah, absolutely. So we leverage some traditional structured analytic frameworks to help guide us in how we suss out different behavioral models for threat actors. Of course, MITRE attack framework, and actually, for us, MITRE attack flows, a more recent one, is actually a really good model and a taxonomy to follow for different types of adversary behaviors that we're interested in finding. So, looking at those different behaviors and those patterns, an analyst can say, okay, where can I find the data that would inform me about this specific TTP for this threat actor? Inform me about the specific tactic that this threat actor is using, and kind of layer those successively. So you kind of encode that whole taxonomy of the MITRE attack flows into a stream processing platform or capability, and be able to get very rapid insights about those behaviors as they're being expressed in different data sources.
Interesting. So instead of doing kind of live investigations, what I'm doing is I'm encoding my investigation patterns into the platform, right?
Exactly.
And what I get is effectively a near instantaneous response, right?
Exactly.
So I'm
As
no
that,
longer doing live investigations, right? Instead, what I'm doing is I'm encoding the contents of an investigation, right? The things that make up an investigation, those actions, and then those actions become an automated piece of the workflow.
exactly. Those known behaviors that exist in the frameworks, there's no reason to have those running in a batch job or a manually driven hunt process. When you know what to look for, we can very easily define patterns and deploy those to be real-time stream processing jobs to kind of suss out those behaviors. And it's also a more iterative approach to threat hunting and threat intelligence analysis in general, where you can continuously re-leverage previous lessons learned and previous findings, and you'll be able to see those results in real time without having to run a hunt or do a query. Just deploying these things to a stateful stream processing platform enables an analyst to kind of continually advance and look for the next new thing or the next finding or the next indicator that they want to bring into those patterns.
So when we're building these, I don't know, is filter an okay way to refer to it?
Yeah.
Okay, so when we're building these filters, do we build the filters kind of end to end, or do we build the filters as consumable components? Right? As in, I want to build a filter for. I'm going to use a really rudimentary example, right? I want to build a filter for traffic from China, traffic that looks like it comes from a bot network, traffic that is going after this specific kind of critical flaw. Would I build that as one thing, or would I build that as three things that I can then use as recomposable components for future activity? Like how does that look?
Really good question. Yeah, and it's really centered around the most basic concept that we can put into one pattern so that you can reuse it. It's almost like a functional programming language. You build a basic function that you can import into all different parts of the application. And the same way is true for stream processing. We're looking for things that can look for a condition or filter out some data to keep shrinking that haystack. And we have this concept of hierarchical complex event processing, where you have all these different components, and usually the field starts very wide at the bottom, and eventually it filters up to certain conditions where you have a very specific finding that you're looking for. But each one of those components that kind of builds up this chain or this pyramid can be reused, across different patterns, so that you're not reprocessing the same data, or duplicating inputs or things like that. So that keeping them really functional and tight to the specific task of that pattern is really a key, so that they can be re-leveraged for additional types of analysis.
So it kind of leads me down the path of there's a best practice conversation that seems like it sits right here in our conversation, right? Which is if I think about this like Legos a little bit, I don't want everything I create to be a one-piece block, a two-piece block, a 1x1, a 2x1, a 2x2, a 4x4. I want to have a little bit more structure than that. Otherwise, I'm going to end up with a whole bag of things that I have to reassemble every time. Right. At the same time, I don't want to get too deep where a house always looks like the same house, as an example. Right. So there's got to be like a best practice around level of subassembly, if that makes sense.
Yeah,
right.
absolutely.
So do you have any like tips or tricks for people as they're kind of thinking through how this process would look? Like what's too generic and what's too predefined? And is there some sort of best practice there?
I kind of think about these things that fall into two different categories when we're constructing these stream processing jobs. One is analyzing the data to produce a specific type of finding. And then, that finding could be, like new process created or, combination of process and, call to newly registered domain. Those kind of things can be like some subcomponents. And you have all these different data manipulations, data analysis, and computational functions that kind of boil the data down to a specific discrete finding. And then there's a kind of a higher order level of patterns, which is where those, kind of more robust taxonomies come into play. So you can then properly classify that event to which type of behavior that belongs to. So there's a lot of different data processing layers and, different joins and maybe some stream processing, some stateful stuff like waiting for the next condition to see if it happens before it produces a finding. And those are all kind of like the base layer of the data processing. And then the top layer is really where that intelligence, that automated intelligence analysis kind of happens, where we're applying different things like frameworks, patterns, structured analytic techniques that really start to produce intelligence findings rather than just more data.
So it seems like logically you would build things differently for insider threats versus external threats. To use the new process analogy, right? If I have a user that's logging in from the same place they've always logged in from, I was going to say on-prem, but that doesn't necessarily matter anymore. But let's say they're logging in from someplace I have seen and thus trusted, and their role is such that they would add processes, right? They're a system administrator. That's probably a different view than the prior things changing, right? Like they're not logging in from a trusted network, or they're not a user that is part of my sysadmin group, right? So there's got to be some like behavioral analytic component to this that you also are gonna want to look at. And then additionally, you probably want to think a little bit about like what are the threats that you're trying to manage, and think about the assembly of these. I'm going to stick with filters. The assembly of these jobs in such a way that they have some relativistic focus to them.
Yeah, exactly. There's there's kind of a lot lost on the signature-based detection processes, and what you've described is a great example of a behavioral model. If we don't have that IP address classified as malicious, would anything catch it? Probably not. But looking at user behavior, we have we've used some interesting, very basic components. Bayesian belief network, which is really just a fancy way of saying logic table. You're looking for a series of conditions, and if you have 4 of those conditions that are true, or 2 of them, or 1 of them, each one of those things can mean something different. In our case, it's measuring risk. So if all 4 of those conditions match, like new IP, different user agent, all these different things that we can see in the data, you're slowly and incrementally building yourself up to something that looks bad. And analysts will be able to look at that and determine that's bad. But a lot of those signature-based detection models just really struggle with it, because you always have to have the indicators or the specific signature. Whereas dissecting these things from a behavioral standpoint and incrementally building a more clear picture of whether this is malicious or not, those things are definitely doable in stream processing. And some of them are very difficult to do otherwise. We use a lot of sliding time windows in some of our analysis. And things like this, if you're trying to structure a query in a lot of the different types of tools that are available for cybersecurity analysis or threat intelligence analysis, that is not a trivial task. And it's pretty computationally intensive. So there's just a lot of other components that are uniquely available when you look at this in a streaming concept versus a store and query manner.
So the advantage to store and query still exists, right? Like if I'm doing an investigation, if I discover something anomalous that turns out that is a threat, right? The ability to take a look back in time for things that I didn't know to look for, at the time the data was fresh, is still valuable and important. So how does this platform, this version of threat intelligence, help to kind of compensate for that in an investigation post incident where I'm looking for something I didn't know to look for initially?
Yeah, good point of clarification. So yeah, I kind of visualize this as a component that like sits in front of the SIM. There's still a lot of utility to having that forensic data to go back and look for. But there's some different types of data that just don't make sense, or maybe are just too expensive from a volume perspective to store in a SIM. Things like DNS logs, NetFlow, all these different kind of things that happen to be very high volume telemetry. Some of those things are kind of unruly or very expensive to store, and so they might get dropped now or not utilized, or there's some different scenarios there. But having as much data as you can, and for reconstruction or investigations is not going to ever go away. I think what stream processing can kind of help out with is all those different kind of conditions that would be very computationally expensive to do, or would require an inordinate amount of volume of data storage in order to accomplish. So in addition to those kind of behavioral elements and those kind of things like sliding time windows and some other concepts that are really good fits for stateful stream processing, I see it as something that kind of sits in front of the SIM, really.
So this becomes more of your kind of like active work versus investigation and look back.
Exactly. This is these having that SIM and the data to kind of go back and look through it, and maybe you find something that you didn't know, or something that wasn't already part of a streaming pattern. Those findings are almost always going to be found through investigations and huntings and lessons learned. But then you can go and develop a pattern, persist it to a stream processing job, and now you have that finding being produced continuously, so that you no longer have to go hunt through the data in order to find those things. You'll just be notified or have a feed that kind of produces those events.
Sure. I mean, it seems like, to kind of double click on that a little bit, right? My SIEM has two different values in this new paradigm. The first value is the archival look back, right? The long-term look back, which we just talked about. But the other one also seems to be the kind of, it's probably not going to sound right, but almost like a test dev area for things to add to the streaming platform.
Yeah,
right?
absolutely.
Like I can, because I should be able to use my SIEM to go, hey, I just saw this behavioral attack exposed. Let's go back and look at our data. Let's see if we can put it together to get the query that we need. Now we can push that. Okay, cool. Now I know what all that logic is. Now let's push that logic into the data streaming platform, making it available to to all of my analysts. Right? Because exactly. I don't generally want to do I don't generally want to play with things in the primary platform that my analysts are looking for to see what is the action that I need to take. Right? I don't want to generate a bunch of false positives. Right? We've already got a problem with alert weariness within the space. Right? So it seems like that would be a solid strategy to leverage the things that you have, and that you obviously need to keep, while staying abreast of threats with a real-time platform.
Yeah, absolutely. I mean, they work hand in hand. I mean, in a scenario where you find an interesting behavioral pattern, like maybe there's a process that's abusing Windows background intelligent transfer service, and that alert leads you to an indicator, an external IP address. Maybe it's some kind of malware C2 or something. You can then take that indicator, and now you can go search in your SIM, and you can find all the assets that have interacted with that, even if they had not expressed that specific behavior that was brought up in the platform. So these two things are really symbiotic in that way. You can stream the more complex behavioral patterns and these higher level concepts that are really more of an analysis perspective. And it helps you gain some leverage on those types of behaviors, where you can inform specific actions and activities that are more specific about certain indicators. And so yeah, it's kind of big feedback loop cycle.
Yeah, I really like the ability to go, hey, we just saw this thing. Let's go search for it and see if it affected us. Let's put it in the streaming platform, right? So that we're instantly aware. But also, let's take a look within the SIEM and see, just because I'm not seeing the behavior right now doesn't mean I've never seen the behavior. But also, Because the SIEM contains all that legacy data, I also have the ability to check my scope, right?
Exactly.
Within the data streaming platform, is my scope correct? Well, here's like an archival look at all the data that I have. Do these scopes match? Do the results show me what I would expect to see if this were a problem, even if it's not necessarily a problem?
Exactly, and having that data for those those different findings historically is also really important, because if you want to develop a pattern, you don't want to use synthetic data, because it's always like, I mean, you're fraught with edge cases, especially in cybersecurity. So to be able to pull out actual event data and construct a scenario, and then essentially test that scenario against the stream processing, it's just these things go back and forth, just in a cycle. But you're gaining a ton of leverage out of the SIM and that archival data. And then you're also getting a ton of leverage by being able to persist, different types of findings or behavioral models to stream processing.
For sure. It also seems like if I do this properly, I probably don't need the same depth of archive in my SIEM that I have traditionally been maintaining.
Yeah, certainly you can be more, more specific about the types of data you're storing. I mean, we also do the same thing. We still have a data repository for certain data that we know is like, this is long-term value. But there's certain data sources that are extraordinarily high volume, where that value is very short-lived. So we kind of tier those things off, and even within the stream processing platform, that data gets tiered off very rapidly, because we know there's a maximum window where this data is useful,
Right.
and we can adjust it accordingly. And so we don't have to store and maintain that data to get the benefit of it, even historically, because the findings that we publish from that analysis are the interesting stuff. So we're able to take these, things that are just incredibly high noise, things like net flow, and distill them down into a set of facts, instead of having this massive mountain of data to deal with.
So can you distill those down to a set of facts and then stream that into the SIEM for archival purposes? Is there value in doing that?
Absolutely. Things like compacting data, it's like, as part of that like data processing layer in these patterns. There's a lot of different operations that can be done to summarize information or produce groups of findings together with context that otherwise would have required storing, this data set, that data set, that data set. Now you can kind of combine them, produce the findings that you're interested in, even if they're not used in an analytic pattern. You can still persist on the storage later. So there's lots of flexibility in how you really develop data models, and how you can use that capability to kind of shrink the haystack a little bit, both from a data storage perspective and an analytic workload perspective.
Okay. So today, I think most medium to large enterprises absolutely have security teams, right? They have many people in security. They have many security tools. They likely all have a SIEM. As they start looking at this platform, or similar platforms, data streaming platforms for the purpose of threat intelligence and security, they're not likely to have all of them to have the most evolved data science practices, right? And what we just talked about kind of gets into data science.
Yeah, it does. Yeah, I look at a lot of the behaviors of the analyst, and a lot of times threat intelligence analysts and cybersecurity analysts don't realize how much data science they're doing in their head. And really, I think that a good concept for the stream processing is to break one of these things down. When you're doing a hunt, break it down into the most specific elements you possibly can. And what you'll wind up with is basically a data model. Although analysts don't think of it that way. We're very driven by intuition, and curiosity, and so your head is doing all these things subconsciously almost. But if you take a second and slow down, and you realize, like, okay, I found this, let me reconstruct the path of the different data sets, and maybe try to summarize, instead of indicators, maybe summarize these things in a broader context or a behavioral context, or leverage a framework. Then you start to you basically wind up with data science. So that the analysts are probably subconsciously doing the stuff on a day-to-day basis. They're just not decomposing it in a way to really make it scalable. And that's what really, I think, the stream processing will be kind of the next big thing in cybersecurity, because it really allows that analyst to kind of decompose their thought process, or that subject matter expert's process, and persist it, so that a team of analysts can benefit from their methodology or their processes.
So my next question, and I've got an answer for it, so I'll include that in my question, is for people that are listening to this and thinking about, ooh, that means I now need to learn something new, right? Anytime we're trying to change thought patterns, anytime we're trying to change kind of the way we work and move beyond our assumptions, right, or our habits, it means we need to learn something new, and oftentimes that can be a little bit burdensome. My recommendation is people buy a book called Pragmatic Thinking and Learning, because it really helps you kind of break things down into those logical steps and think about things from both the big picture and the kind of the micro and the macro view, and then allow you to put it back together into a story. Jeremy, do you have some places that you recommend people go to learn more about kind of this data science style of thought process, and then obviously the execution?
Yeah, I'm a really big fan of structured analytics. There's a diamond model for intrusion analysis, one of the big staples in the industry. And there's also the MITRE ATT&CK frameworks. I mean, they're very prevalent and they're also extraordinarily useful. Being able to communicate in a common language and a common methodology is critical to being able to build scalable, sustainable analytic practices. And there's a lot of material that's also available. Maybe it's even more traditional intelligence practices. There's several books on structured analytic techniques, that are kind of on the favorites list for National Intelligence University. And there's a lot of lessons to be learned for analysts of all flavors on looking at some of the oldest analyst shops in the industry, which are the intelligence agencies. Looking through those processes, or looking at, how do they conduct counterintelligence? There's always a structured analytic technique or a methodology that translates. These things are really a science, and a kind of a blend of a science and an art. And a lot of those things that are used in traditional intelligence tradecraft are also very applicable models to use in cybersecurity and threat intelligence analysis.
So I'm going to take an aside here for a second, then I'll bring it back. But when science was in its youth, at the kind of dawn of science, which is not the dawn of man, it's much, much later, right? We're talking like 16th century kind of time period. Alchemy was the competing practice to chemistry, right? Do you know why chemistry won and alchemy lost? And it's not because one was foolish and the other one wasn't.
I would say that alchemy was probably largely based on experimentation, and chemistry was really more based on understanding fundamentally different properties and behaviors.
So the net result is basically what you said. However, the way we got to findings in chemistry was building on the findings of everybody that came before, right? So chemistry was public and had a scientific model to it that everyone agreed to follow for it to be called chemistry. There's some nuance, but that's not the purpose of this. This is not a scientific podcast. Alchemy, on the other hand, was every alchemist kept everything they did secret from every other alchemist, right? And so there was no public model that you could follow. There was no public repository of information. You couldn't build on what all of the other alchemists did the way you can with chemistry, which is a science. And that's kind of fundamental to science, right? Not only is there a model, but also there's a requirement of publication, which includes the word public in it, that allows everyone else to look at it and go, ooh, I agree, I disagree, this is why I agree, this is why I disagree. Here's where you failed to follow the scientific model, right? Like we do that kind of peer review as an active process within all science, and data science is no different.
Yeah, it's funny. I'm actually gonna steal that anecdote because it's a really good description of even how a lot of different threat intelligence is done in the industry. It's like we tend to like squirrel away a lot of knowledge and keep these things in subject matter experts and specific techniques that are based on the individual, rather than trying to build these things into higher order thinking or patterns that can be kind of persisted, where that knowledge can kind of be re-leveraged by other users.
Yeah, I mean, it's interesting, right? If we look at data science, the things we commonly do become publicly available models that we use, publicly available libraries that we use within data science, right? Sure, there are proprietary algorithms, but proprietary algorithms are actually the edge case, not the core case.
Right.
And yet we don't actually have the same thing within cybersecurity, right? Like the threat intelligence Process, sure, it's well documented, to your point, right? The MITRE ATT&CK framework. But the model that we create, there's no centralized repository of those models that we all share, which I think is a shame.
Yeah, it's a really interesting concept, and I think that as we look at even things like counter insider threat, there's a really robust model for counter insider threat that's based on the Soffit model, this great model. But it's when you have a common platform or a common methodology, if one agency wants to use that model, they can now kind of benefit from all the pre-existing work that's been done. And not only that, but they can communicate cross-agency about issues, breaking down a big silo. And so that when you're kind of all working from the same platform or the same concepts, even if there's cross-functional teams, like in cyber, you may have a fraud team, you may have a network security team, but if we're leveraging the same models in the same platform, it becomes very easy to collaborate on a lot of issues that are probably sharing a lot of the common data, but would otherwise exist in silos.
So there's another concept that I think plays into this, and that is, I'm a firm believer that there are only two markets that you compete in, whether you want to or not. The first is the currency market in whatever nations that your company operates in. You have no choice. You are absolutely participating in the currency market. And the other one is cybersecurity. Right? Almost every other thing in business, I can choose to participate or not participate. If I don't want a website, I don't have to have a website. If I don't want a mobile app, I don't have to have a mobile app, right? If I want to ship the products myself on my own trucks, great. Or I don't buy trucks and I use a third party. Or I deliver digitally only, right? I have a tremendous number of choices. However, I do not get to choose whether I compete in the currency market. I participate in the currency market, excuse me. And I do not get to choose whether I participate in the cybersecurity space or not, right? I can choose to simply not field a team, but the other team still shows up.
Yeah, exactly. I mean, if you're going to be leveraging the internet, which I mean, almost every business does in some way, even for just communications, you're creating that exposure, and it's inescapable.
Well, I don't think the internet is the trigger. Right? Otherwise, there's a whole bunch of military units that would have no need for cybersecurity, and yet, right? Classified system, disconnected systems, those systems that have no public connectivity still invest a tremendous amount of money, effort into cybersecurity and security prevention, right? So I just think you participate, period, end statement. I don't think there's a disclaimer attached to it.
Yeah, can't forget SneakerNet.
Right.
Yeah.
You can't, the cybersecurity researcher that figured out how to recompile data by watching the flashing lights on the storage array from a building across the street says, I don't need the internet to do that. There's no internet attached to that, right?
Very good point.
And so, like, the second thing that I would say is we also seem to think cybersecurity is a me problem. Right? Kind of back to what we talked about before, where we don't talk about our techniques. We don't talk, unless we're a researcher, unless we're a public persona, we don't talk about our incidents. We don't talk about the things we've figured out to help stop the problem unless we're paid to be on stage to talk about it or are a researcher at something like a B-Sides or a DEF CON.
Right.
And I think we need to change those. Right? Like,
Yeah.
I don't know a case where cybersecurity should be viewed as a competitive advantage. Right? Because it's us versus the attacker, not us versus the company next door, or if I'm in manufacturing, the other manufacturing companies. Right? I think we need to get to the point where we're much more open about this, where we're much more, and I don't mean we talk about the incidents we've had. I mean, we talk about the techniques that we use. We build on each other's knowledge and framework in a very, very, very open and honest fashion. Right? Take the tool. Here's a tool I built. Take the tool. Here's an algorithm that we wrote. Take the algorithm. Use it, please, dear God. Right? Because we're not competing against our competition in the market. We're competing against the security bad actors. Right? And I think we need to reframe the conversation and start encouraging that level of communication.
Yeah, it's definitely a large enough problem, and it's not going to go away. So if we look at collectively trying to solve these different issues, especially around analysis, I think that one of the great things about using stream processing is that it's not based. You can make these behavioral patterns that are not based on indicators. So I think there's a lot of hesitance to share or everybody wants to put TLP orange or red on certain specific things like IPs and domains because they're afraid that can be somehow linked back to their organization. And being able to abstract these things to kind of higher level concepts or specific behaviors really negates all of that, because none of that information could even be remotely construed to attribute it to some previous act to a specific organization. So I think that there's a lot of opportunity there to publish very openly process and methodology on threat actor detection. And I do think that this concept of stream processing, is going to be one of the things that helps open that aperture a little bit, because you really gain the most leverage with this concept when you really boil these things down to behaviors and broad classes. It's like I love to look at set theory as a guiding model for stream processing, because these are a lot of very broad set operations where independently they're not doing much, but when you look at the cumulative fashion, how it's kind of how your brain slices these problems as well. There's just a lot of opportunity to describe these things in very broad syntax, really.
Yeah, for sure. Interesting. It also seems, as we start to move into stream analysis or threat intelligence using data streaming, because of the real time, it becomes more and more and more valuable that your filters are also real time. Right? That you're able to put a proper filter in place as soon as an RFC is released, as soon as a threat report is released. So that also leads us more towards we are really motivated, because we're looking at things right now, this very second, to start sharing that information, right? And so maybe somebody listening to this that runs a nonprofit or a government agency can start thinking about funding said third-party nonprofit agency to capture, publish, and make available this sort of information, right?
Yeah.
I think we need to get there for sure.
It's actually funny you mentioned that. So I actually did start an initiative with a nonprofit, a university affiliated nonprofit, actually in Iowa, kind of around this concept, but it is difficult to get funding.
It's difficult to get funding. It's difficult to get funding for everything today, right?
But I would love to take all the data that we have available and just give it to researchers and masters and PhD students to really find the value here and help guide policy. That's kind of one of the reasons we went up there is there's a program there that's kind of a computer sci poli-sci major, and so or political science major. So you have this kind of unique opportunity if you have somebody that understands the technical depth and nature of the data, but they also are getting kind of the policy exposure, because more than anything, we need really smart people making these policies so that they're effective in a way that everybody benefits. And so, it's a much broader tangent, but yeah.
No, but it sits with something that's near and dear to my heart. I was the CTO for Hitachi Vantara, and when I was there, I was also the lead commenter on legislation, right? Hitachi has a lobbying arm, just like every other company does. And so when there's technology legislation, it would often end up on my desk for comment. And my comment was almost always, does no one on either side of the comments understand how the technologists don't understand how the law works or the intention thereof, and the legislators don't at all understand how technology works and what the capabilities are.
Yeah.
And so it was really interesting to kind of read through, because you get effectively text, but also all of the comments. And it was really interesting to read through that and go, oh my God, this is horrible. Oh my God, please don't do this. Oh dear God. Oh my God, it's all on fire. So it's really interesting to hear that there's a program that's trying to kind of overcome that. And I agree with you. I think it's something that's extremely necessary. The stuff doesn't get easier. It doesn't get simpler, right? During the hearings on CISPA with Congress, which was a massive overreach by legislators and lobbyists to try to restrict the internet. But one of the things that CISPA attempted to do was make it illegal to resell a product without a resale license, right? So if you bought a Coach bag, for instance, you'd have to have a license to resell that Coach bag on like eBay. Okay. So the question was, and they're asking the question of the gentleman who worked for Google, who is the world-renowned expert on image analysis, right? And this guy developed algorithms that effectively wiped out child pornography from the internet. He was able to develop algorithms that recognize child pornography and simply delist it. This is the most massive positive change I've ever seen from an analytics program ever. And it changed that field significantly in a hugely powerful way. But this guy's the renowned, like the world expert. You ask anybody else that's an expert, and they say, no, go ask this guy. So he's the witness being asked questions. And they say, we'd like to do this. And he says, cool. So yeah, we can absolutely develop an algorithm that looks for imitation coach purses, and then we'll flag it and you can delist it. And they said, no, that's not what we're looking for. What we want to do is look at the image of an actual coach purse and be able to tell if someone has the resale license. And he goes, based on like a database that you have? No, based on the image. Right. That's not containing the image. Like, this is a legitimate coach purse? Yes. Yeah, that's not containing the image anywhere. Right? Like, the data doesn't exist, therefore no algorithm can determine based on no data, right? Like, totally logical, totally reasonable. Every technologist goes, yeah, okay, of course. The response from the congressional members was, my daughter's pretty good at computers. We've got some pretty smart people. I'm sure we'll figure it out. Moving on.
Magic.
They then spent an hour talking about what they'd order for pizza for lunch. Right? Dismissive of the worldwide technology expert who said the data simply doesn't exist within what you're looking at. Therefore, it cannot be done. Totally dismissive. And that's the delta between the two.
Right.
It's like
a big chasm to cross.
it's huge. And it's a chasm that we have to cross because this is not getting easier. Right? The other side doesn't have rules. Right? When you're a threat actor, there are no rules. The rules are you take what you can get. It's piracy. Right? It's modern piracy. So we can't be behind. We can't be slow. We can't continue down this path of ridiculousness from a legislative standpoint and ignorance from a technology standpoint. Right? We have to bridge that chasm, and we have to all do it willingly. Anyhow, that's a little bit too much of a tangent. For today, what I would recommend for all of our listeners is start thinking about this evolution of threat intelligence. Start thinking about, as threat intelligence becomes truly real time, and as you're looking at streaming data, you need to start thinking about, how do I define behavior within my organization, and how do I attach risk to behavior? Any final thoughts, Jeremy, before we say goodbye?
Very well said.
Well, fantastic. Well, this has been another episode of DDT. Please like, subscribe, comment. And if you'd like to be on an episode or like to see someone on an episode, please reach out to us. You can find me on LinkedIn at Howard Holton. And Jeremy, how can people get a hold of you if they want to learn more?
Yeah, we can be reached at Cogility.com. If anybody wants to reach out to me specifically and talk about, threat intelligence, I'm Jay Turner at Cogility.com. And, I live, eat, and breathe this stuff. And I appreciate the conversation, Howard. And I'm happy to speak with anybody else on the subject as well.
Great. Well, this has been a ton of fun for me, and you've given me a ton to think about. So I'm gonna spend my next break kind of considering everything that I heard today, and really giving it some thought, because I hadn't thought about data streaming within threat intelligence. So this was a really welcome conversation. I really appreciate it.
Thank you. Thanks for having me.